Well, thank you for having us. I appreciate y'all coming during your class period and giving up your learning so that you can learn our stuff. So, who's heard of NASA before? Yay, almost everybody in the room. Does anybody know what the N, the A, the S, and the A stand for? What? That's correct. National Aeronautics and Space Administration. NASA was formed in 1958, and they are responsible for all of our space travel. They coordinate crewed and uncrewed missions. Uncrewed is the stuff that we do. We do not send humans into space, but we work in one of the many programs at NASA. So this is the NASA logo. It's called a meatball. It is the big blue circle represents a planet, and they made it blue because it could represent Earth. When you look at Earth from space, it is blue. It's beautiful. The white dots are, of course, stars. And then the red wing, it represents the aeronautics for flight. And then the orbiting item represents space travel and orbiting other planets or other celestial beings. So this is a map of the United States that shows where the NASA centers are. There's 9 NASA centers. We got a couple of them in California. They're mainly research. Up here in the Mideast, the Northeast, those are also mainly research centers. Headquarters, we got Marshall in Alabama. Johnson Space Center is responsible for the astronaut training as well as mission control. When we have anything in space, with humans in space, they're the ones that communicate with the astronauts. When we launched, like the shuttle program, for example, we did all the preparation, the operations, getting the shuttles ready at Kennedy Space Center, which is down here. We would launch from here, and as soon as they were in space, Johnson Space Center took over and managed the entire mission. So Katie and I are from Kennedy Space Center, east coast of Florida. We are very cold. It's cold in Kuna, but that's why she's wearing her jacket. It's cold. So that's where we're from, and we just would like to share with you what we do and what NASA does in hopes that it will inspire you to stay in school, study math and science, or whatever it is that you're interested in, and be very successful in life. So this is me. I grew up in Memphis, Tennessee. Elementary, middle, high school, college there. Went to the University of Memphis, and I got 2 undergraduate degrees, one in microbiology and the other in medical technology. And when I graduated, I went to work in Florida. I moved to Florida. I said, I want to live in Florida on the beach so that I can enjoy the sand and the surf and all that other stuff. So I got a job in a hospital lab right there in Rockledge, Florida. And I worked there about 2 years before I realized I absolutely hated that job. It wasn't what I really wanted to do. So I looked around and said, well, what else can I do? And it turns out that I was right there by Kennedy Space Center. So I ended up getting a job in an environmental microbiology lab. After all, I did have a degree in microbiology. So I worked there for many years, and I just continued looking for new opportunities to increase my skills, increase my education, and I just greatly enjoy my career. So a lot of the companies that are aerospace related, they invest in you as an employee. And the companies that I worked for invested in me. I was able to get a master's in business administration from Florida Tech, 100% paid for by my company. Then I went on and got a second master's degree in industrial optimization, again 100% paid for by my company. And then I've gotten 2 additional certifications, a project management professional and a Lean Six Sigma Master Black Belt. And as I moved through my career, I just looked around, saw what looked like fun, kept my eyes open, and if somebody asked me to apply for another job or move into their department, I just said yes. May not have been completely ready for it, but I learned it once I got there. So I hope that you will keep your eyes open for opportunities in your life and your career as well. Hobbies? Play pickleball. Anybody play pickleball? A couple people. It's fun, isn't it? It's a lot of fun. I walk my dog, I snow ski, play board games, stuff like that. Okay. So the Launch Services Program is all about launching spacecraft into space. And we are kind of like the middleman between the scientists who are building their spacecraft and the rocket providers that launch the spacecraft. So when the scientists are ready to get started on their experiment, they reach out to us. We give them some guidance on the size and the weight and other things associated with their spacecraft. Once they tell us where they want to go, when they want to get there, what they want to do when they get there, how big their spacecraft is going to be, how heavy it is, then we take that information and we decide which one of our rocket providers would be best for giving them a ride to space. And once we decide that, then we purchase the rocket from the rocket provider and we work with them throughout the rest of the process until their spacecraft is in space. So we call ourselves the Earth's Bridge to Space because we are the link between Earth and space. So that's our tagline. So I've kind of told you about what we do, but I'm going to show you what we do next. And there's a little bit of audio with this, so I will put the microphone so you can hear the audio. Okay, we saw a couple of rocket launches, saw a couple of different spacecraft. We saw the Mars rover, the little Ingenuity helicopter that we put on Mars. Pretty cool stuff. So that's what we do, is we work with the scientists, figure out what their spacecraft is all about, get them a ride to space, and get them into the right position so that they can do their science. We've done lots of different kinds of missions. I'm sure you heard about the hurricane that we had a couple weeks ago, Milton and also Helene. Well, a lot of that information that they learned about the hurricanes in advance were from the weather satellites that we helped launch, the GOES-U systems. They're the ones that have been helping us understand what's going on with our weather. We did, like I said, the Mars rover, the little helicopter, the Ingenuity helicopter. Its mission was to fly over the the Mars surface, and collect information. And it made 72 different flights on Mars before one of the rotors broke and it stopped working. So the rovers, the satellites. Has anybody heard of CubeSats? A couple people have. The CubeSat is a box. It's about a 10-inch by 10-inch box. And you, meaning educational organizations, high schools, colleges, they make a proposal to NASA for an experiment. And if you're selected, they give you money to build your experiment, and you put it inside that box, that CubeSat box. And then we launch those experiments into space for you. And we link them together so it may come like a matrix. And then when we have a primary mission that has some extra room in the fairing, the top of the rocket that contains the spacecraft, then we add additional smaller experiments like a series of CubeSats so that they hitch a ride to space with the primary mission. This is our logo. This is the Launch Services Program. We've got the NASA We've got our Earth's Bridge to Space tagline, and then we're at Kennedy Space Center. So it looks like a compass. And then this is the Earth. You can see that part right there. And then, of course, the rocket launching up. And then the stars on either side. The Launch Services Program was created in 1998. So there's 9 stars on the left side of that, and there's 8 stars on the right to symbolize the year that the Launch Services Program was created. So that's our logo. Now Katie's going to introduce herself and talk about the rockets.
Okay, so I work at NASA LSP, but my journey into STEM was not conventional. My parents, neither of them went to school, and I was just in a small town in Tennessee. I got into it because I stole my brother's toy rocket and learned I like to blow stuff up. And I kept going from that. And it kept growing and growing and growing, and there was a few accidents. Some fires started in the backyard and those things. My parents, thankfully, were very nice and channeled that energy and got me enrolled in the National Association of Rocketry. It is a club that you guys can join. They do launches, and I think there's a few chapters in Idaho. I'm not sure the location, but you do get to meet up and you basically get to light up the sky. It's a lot of fun, and I was launching almost every weekend at a different location all the time, and it's absolutely incredible. I got all the way up to level 3 in high power rockets, so I could launch them as large as that. And it actually got me into scholarships, and I met my future mentor at Los Alamos National Lab from that. And she told me I should major in physics because I like to blow stuff up, and it'd be, interesting to see why the physics and things happen. So I went with physics, and I interned under her every summer at Los Alamos. And upon my undergraduate career, you have to have a PhD to be what's called a principal investigator or to do research. I picked England because they have a lot of research in the sun. And the reason why the sun is my favorite object, the sun is a giant ball of fusion. And every solar flare is basically a nuclear bomb. Solar flares were actually discovered because the United States was looking for nuclear bombs from Russia. It's the same signature. So it's a free lab in space. So I got my PhD in astrophysics. And one of the cool things I got to do is, in 2018, I got to go to Russia and learn some of their solar observatories. So this picture, let me get this one. This is an old solar array. So these are radio telescopes, and they were originally built to spy on the United States, looking for nuclear bombs. But they converted it to a solar array telescope. So now the array was completely reconfigured and points towards the sun. And I got to go there. It was absolutely cold. I couldn't even wear contact lenses. It's so cold because, it would freeze and cut your eyeball. It was awful. Hated it. I hate the cold. I do not do well in the cold. And I quickly came back to Florida and promised I would never experience winter again. And I will never leave Florida now because of that. But fun fact, this little creature here was actually named after Arco, Idaho. So that's my dog Arco, and this is her. She's criminal here of the crime of trespassing, because she's not supposed to be over that fence, but so she is a felon now for trespassing. But this was the day that I got my PhD at NASA, but that is Arco. But has anyone seen the Avengers movie? Okay. Did you guys know Tony Stark's lab is a NASA lab? So this lab here is the Neil Armstrong testing facility in Sandusky. It's been around, I want to say the 50s, but don't quote me the decade. It was designed to measure, it's a chamber, and it looks like a silo in a farm. People probably think that we were keeping aliens inside it. We weren't. You wheel in either a spacecraft, satellite, or a fairing into that chamber, and you can actually empty all of the oxygen in that chamber and create a zero atmosphere situation. You can also measure different electromagnetic issues with that. So a satellite has to be safe inside of a nose cone, and you cannot have certain frequencies come inside and damage the instruments. You can also make extremely cold temperatures in that chamber to see if a satellite survives. It's a really useful chamber. I got to go there for a month. It was awful, 13-hour days, but worth it, and use the chamber. I do think the Tony Stark, I think he had a better video of it than what we have, but very useful. Now my job is, I am kind of using astrophysics for radiation. So the sun goes through different cycles, has a solar min and a solar max. I create the prediction for that cycle and submit it to NASA, and they send it out to the different centers, and they use that for planning the radiation environments and the future trajectories that will be happening. And we have to always measure what the radiation will be. We also do lightning studies, which is interesting, but I'll go into more of that later. So let's go to the next one. All right, so this is a pad. We don't actually launch straight up into space. That would cost way too much money and be way too hard. Great, you're just going straight up. You actually launch at an angle, and you usually aim it towards Africa from Kennedy Space Center, but there are a few going up the coast. We do go over the ocean. Reason is, if something bad does happen, it happens over the ocean and not over people's homes. The second is, if it does go off course, it is blown up. And that has happened a few times. Nothing on anything major, but it is actually a job. You can go to college, get an engineering degree, and be trained in command destruct, where you will be the person who sits there with the code on how to blow it up. Speaking of career opportunities. But we do rely on the booster to get all the way up to a certain altitude. And once we get to that altitude, the boosters are dropped or flown back, if it's SpaceX, and it continues on to its trajectory. There are 4 cameras around for monitoring in flight. We also have a few cameras inside, because inside the rocket, the liquid propellant or the propellant does move around. It's called sloshing. And that can actually slosh so much that the rocket is pushed off course. Has anyone heard the phrase, Houston, we have a problem? Yep, that was actually a sloshing caused the trajectory of an Apollo mission to go off course. So we do monitor it now. All right, we do have, so LSP, we act as homework checkers. So you have the launch provider, the rocket that provides the ride up. They're the taxi service. Then we have the customer, the spacecraft. They're getting the ride. Now we have to make sure that the spacecraft has done their stuff correctly, their engineering analysis, so it does no harm to the launch vehicle. Then we have to make sure the launch vehicle has done their stuff. So we're constantly checking both ways that everything is okay. But we have different options for the spacecraft to have different rides. And the spacecraft has the option to decide which one is best, depending on time, money, and need. So here's our fleet. My personal favorite, this cute little guy, Pegasus. It's tiny. And it can launch 1,000 pounds into space, which is the size of my horse. So relatively cheaply, you can send a horse into space. It started in 1991 as a low-cost option for stuff like weather satellites, I think a few small communication satellites, so smaller things. And it went till about 2021 until it was discontinued. And the idea was it would go up and the pilot would just drop the rocket like a missile. Second option, United Launch Alliance with the Atlas V. The Atlas was something that could handle things much heavier. Now, it's a lot more expensive. So the order of magnitude for these to be built is about 100 million. So a lot of money to build these things. And they can launch about 2 to 3 horses size in space, so 2,000 to 3,000 pounds. A very large, like, think of a space telescope going in. And this was in use for about 80 to 90 launches. But unfortunately, some stuff happened, and Congress has decided that we have to have engines built inside the United States. Because up until 2018, 2020, all of the rockets were manufactured in Russia. So we were dependent on Russia delivering an engine. Does put us at a vulnerability. Well, we had purchased 135 of these ULA, the Atlas V launches. Certain had been used, and so many were contractually left. So we had 35 remaining when this decision was done. We have done about 22 of those launches, and so the remaining have to be used up, and then the Atlas will be retired. Has anyone heard of SpaceX Falcon? Okay. Yeah, it is famous. SpaceX does use social media more, so they are more popular. Now, they have done an interesting thing where they do things on a reusable base. The missiles in the 1990s were in research for reusability. This analysis was used as the foundation for SpaceX to apply it to the aerospace industry. Now, they won some awards and were subsidized to pursue this. They kept going, and they eventually won, where they figured out how to get the boosters to fly back and land at the Kennedy Space Center. Now, they can reuse these boosters and cut the cost down of the launches and make them much more efficient of time, or like the time between launches. Before, you would have about singular digits of launches per year. SpaceX has pushed that up to about 178 so far. Next year, they want to launch over 200. Now, not all of those are LSP missions. They do launch a lot for commercial, like satellite, just like Starlink. They do launch a lot for the military and other programs outside of LSP. Now, we do have, say you have something very heavy that you need to get in space. They just add some extra boosters, and now we have the Falcon Heavy. This is for, obviously, the major and large missions. ULA has now created the Made in America version of the Atlas. This is the Vulcan. These rockets are manufactured by Rocketdyne, and I think they are manufactured in Washington State, I believe, so it's local to you guys. So these engines are made, they're either here or Texas, or Washington or Texas. They have had 2 successful launches of the Vulcan, incredibly successful launches. Once the Atlas is done, we will now be using the Vulcan, which is exciting. Now, who has heard of Jeff Bezos? I figured. All right. Do you think Jeff Bezos was going to let Elon have all the fun? Absolutely not. No. So he created his own company called Blue Origin. Now, Blue Origin has a different philosophy. They call themselves the stealth tiger, because you know how like you quietly approach your prey and then you surprise and jump out attack? That's kind of what they've been doing. They have quietly been doing a lot of analysis and stockpiling parts in warehouses and incrementally going. And so once they get their launch going and having successful New Glenn, their rocket, they're just going to go for it. And they're going to have the power to do so. So their competition directly to the Falcon is the New Glenn. Now this will be launching the Amazon Kuiper project as well. So they will be very busy as well. I imagine Kennedy Space Center will look like an airport. So size comparison. We have the Zion's Bank building compared to the rockets. So it takes all of that to send a satellite into space. This isn't the largest rocket that has ever gone up. The Saturn V is actually, to date, the largest. So it's the SpaceX. What's interesting is, you see these towers? Okay? Rockets generate lightning when they launch through the atmosphere. That's why we cannot launch if there's clouds out in space. It's a no cloud rule. Sometimes lightning does happen, unfortunately. If lightning does strike the rocket, it can damage the electronics, it can damage the launch system, it can damage the astronauts. There's a lot of risk involved. So if lightning were to strike, these towers handle it and redirect it and suppress it. It's pretty cool. Another cool fact, this part where the rocket sits is actually left over from the Apollo era. They recycled it, cut it to make it shorter, and it's now in use. But I mentioned the boosters. So those boosters, once they're dropped, they actually have to fly back and land back at the pad. That is extremely hard from a software standpoint and a guidance navigation control. Extremely hard. But watch how fast they do it. Okay. Now these do return and break the sound barrier. It does cause a double sonic boom. If you're standing in the parking lot at Kennedy Space Center, the car alarms will go off. It's kind of funny. All right, we have the Atlas. Now how you read these numbers, you see this 5? That means that the fairing, so the spacecraft rides in here at the nose cone. That's its little home. It's 5 meters long, diameter. The 4 stands for the 4 additional boosters, and then the 1 stands for the main candlestick. This one, the Atlas 401, so it's, I don't know where the laser pointer is. It's 4 meters long, 0 additional boosters, and 1 main candlestick. And then the Vulcan, it's just had the trials, so there's no numbers yet. Okay, so now we have the Pegasus. In terms of cool careers, there are actual pilots that do work at NASA, and this particular one worked with Northrop Grumman. Some people fly people to Hawaii. This person got to say he launched rockets into space. It's a pretty neat career. It does work like a missile. Rockets are actually classified missiles. The military is actually the ones who oversee the launches. More so, they have to have the military has to have a standing when you do a rocket launch because it is technically classified as a missile going towards space. We are one of the only countries that calls rockets rockets. In other countries and other languages, they are called missiles. We just happen to be aiming them towards space. So it's a missile directed towards space. And so it does act like a missile. The pilot drops it, and then it's going off. And I'll show that video now. Show that. Okay, as a Floridian, I hate the way he says hurricane. He says hurricane, it's hurricane. But they do act, it does drive back up to space. They use these a lot for the weather satellites. Stuff like GOES and those things. Okay. I will hand this off to Bonnie and she's going to discuss where we've been.
Okay. Okay, so I mentioned that we work with the scientists to do their science, their robotics, their exploration, and every word on there, every one of those missions represents a satellite or a telescope or a rover or something that we've launched. And sometimes we put 2 or more satellites in one launch. So we've launched 102 times so far. It's pretty exciting. So these are all the missions that we have completed that are orbiting around Earth. These are the moon. This is the moon, and if we have a few missions that we participated in for the moon. Here's Mars. You can see the landers and the rovers over there. Jupiter, Saturn, Uranus, Neptune, and Pluto. We even sent a probe out as far as Pluto, and it's actually gone past Pluto at this point, looking at what's going on in our solar system and beyond. We've gone to the sun, the Parker Solar Probe, the Katie's favorite mission is the Parker Solar Probe, going to study the sun. And we've been to asteroids, other areas within the solar system and within the universe. Has anybody heard of the James Webb Telescope? Have you seen any of the images? There's some pretty cool images out there. If you get a chance, go to the web and look up the James Webb Telescope. It's pretty cool. So these are the kinds of missions that we've been involved in. These are the missions that we have on our plate. These are the ones that are currently in work, either at the beginning, the conception of the idea of the science, all the way through almost ready to launch. So we have about 70 missions at any time in work. So it's pretty cool. And we have a lot of work to do. And I would like to encourage you, if you have any interest at all in working at NASA or any of the aerospace industries, to come join us and help us with our mission. Because we need all the help we can get, and you guys are our next generation explorers and scientists and engineers and business accountants. We have a huge NASA budget, and we have a lot of financials, human resources, all kinds of other jobs that are available at any of the space centers or any of the aerospace contractors. So I just encourage you, if you have any interest at all, to stay in school, do well, and keep your eyes open and say yes when you have an opportunity. So that's a lot that we have on our plate. I wanted to share one of my favorite missions with you. It's called the Double Asteroid Redirection Test, or DART. We use a lot of acronyms at NASA. And this mission was to fly out to an asteroid and smash into it and try to push it off course. Because a couple of years ago, there was a movie called Asteroids, and the intent of that movie was that there was an asteroid coming that was going to impact Earth and destroy Earth. And that could happen. Absolutely could happen. May not happen in our lifetime, or it may happen in our lifetime. But we wanted to see if we had some kind of planetary defense that we could put in place in the event something like that happens. So we created a spacecraft. We sent it to an asteroid. We impacted that asteroid and moved it off course. So it was launched from Vandenberg Space Force Base. Oops, sorry, I did not mean to do that. In 2021, and it took until September 2022 to reach the asteroid. And we went to an asteroid that had another asteroid, we call it the moon, an asteroid moon, that orbited around that main asteroid. And that's why it's called the double asteroid. So we wanted to be able to measure and make sure that we did something, moved it off course. So we picked a double asteroid situation where we could measure the orbiting of that moon, asteroid moon, and then we could measure what it was after we impacted it to see what difference we made. So that's the spacecraft, that's the asteroid. So here I'm going to show you a video of what that looked like. And that's the DART, that's the fairing where the spacecraft was encapsulated. See, it opens, it releases the spacecraft, takes off. It's going to deploy its solar wings so that it can harness the sun's energy and keep power going. And then it's going, there's the two, did I lose the power here? Yeah, I did. So you saw that's the asteroid we're ready to impact, that we've got it in our sights. That spacecraft is going to hit the asteroid. And boom, there goes our camera. It got smashed. So that's what we were doing during the DART mission. This is what the asteroid and the asteroid moon size-wise. You can see this is the moon. It's called Dimorphos. It's 163 meters. It's about as tall as our Statue of Liberty. And then this was the main asteroid over there, Didymos. And it was a little bit taller than the new World Trade Center. So that's what we were doing, is we wanted to measure how well we moved that asteroid. So this is the Dimorphos, and this white orbit was the original orbit. And we pushed it closer to Didymos, which was the big asteroid. And originally we measured how long it took to make one orbit around Didymos. And our goal was to push it close enough to Didymos that it would reduce the orbit size by 73 seconds. And it turns out that we hit it so hard, we pushed it closer to Didymos than we thought, and the orbit was reduced by almost 3 minutes. So we felt like that was a huge success. So that's what we did. You can see the DART spacecraft there. Here's another image of, this is actual footage of the crash, or the smash. So I'll show you what that looks like. You can see the moon on the right and the other asteroid on the left. And they're getting closer and closer to the asteroid. You can see how rocky and uneven that surface is. And then smash. We lost our camera. Pretty cool stuff, isn't it? Yeah, so if you think of a great experiment, you could work with your teachers and come up with an idea for a CubeSat. They're always looking for ideas. Who's interested in working for NASA? A couple people are. Okay, well, this is how you do it. It's an easy way to get your foot in the door if you come in as an intern. So if you're interested, go to this website, intern.nasa.gov. Look at all the options. All of the space centers have interns. So if you're interested in one in California or one in Florida, you can look at what all those options are. And there's all kinds of opportunities for internships. We have STEM, which is the science, the technology, the engineering, the math, and we have non-STEM, which are the business, the accounting, logistics, communications, public relations, graphic artists, videographers. We have writers, human resource education. We have teachers that teach technical classes. So no matter what your interest is, there's probably something that would work for you in one of the aerospace or NASA industries. All the sciences, the chemistries, the physics, the physical sciences, the robotics, you name it, we've got it. Well, there's two different kinds of intern programs. One of them is through the Office of Science, Technology, Engineering, and Math. It's the OSTEM internship. And if you're in high school or college, there are opportunities for you because they accept both of those high school and college students. You can go to the website, intern.nasa.gov, and look at what is out there. They have 3 times a year that they accept interns, spring, summer, and fall. Some of the positions are remote, so that you can work from your house. You would get paid. If you take a job that's face-to-face, they'll help you with housing and transportation. They give you a paycheck. They'll pay you for your internship, for your work, for the 16 weeks or the 10 weeks during the summer. And they'll help you, like I said, find housing and transportation to get to and from the space centers. This is a non-civil servant position, meaning that you're not going to be an official NASA employee, but you will be working and earning a salary. The other internship, which is really cool, is called Pathways Internship. And this is where you truly are a NASA civil servant government employee. They pay better than the OSTEM positions, They're only open to college students, so if you're interested in a Pathways internship, you need to start planning now. If you go to the website, they have lots of tips on how to prepare your application, what kind of GPA you need to have, what classes are recommended for the different kinds of internships that you might be interested in. These are both STEM and non-STEM positions, and again, spring, summer, and fall, that you can participate. And with the Pathways internship in particular, if you like them and they like you, they'll probably bring you back the next year and the next year until you graduate. And then they'll probably offer you a job. But 99% of the Pathway internships result in a job offer at one of the space centers. It's pretty cool stuff. So if you're interested, intern.nasa.gov. And we'd love to see you in Florida. It's a little hot there. You'll have to deal with the hot summers that you're probably not used to. But we'd love to have you join us at the Space Center. Okay, this is Kennedy Space Center. This building is the Vehicle Assembly Building. This was built for the Saturn rockets, the Apollo rocket era. When they were trying to go to the moon, they would stack the rocket on top of the mobile launcher. And then they would bring a crawler underneath it, pick the whole thing up, and then wheel it out to the launch pads, which were out here. This is the launch complex where they had our operations mission control. And of course, there's another rocket launch. This area here is, we call this the turn basin. When they bring flight hardware, it's usually very large. They could bring it on a big barge, and they bring it directly into there, and then they offload it onto like a tow truck, and then they tow it to the operations buildings. So, what questions y'all have for Katie and me? Yes?
On your future missions, you had advisory and class ones, so is it just like for citizens is one of them, and then one you're advising companies on it? Or?
Okay, so he's asking about the missions. We have 3 different classes of missions. We have where we are the primary integrators, and we do the operations, the integration, and all of the work that it takes to get the spacecraft from the scientist loaded onto the rocket and then launched. The advisory missions, we don't do that, but we advise. We offer our technical expertise for anybody that needs help launching their spacecraft. And then we have a new program. It's called VADER. It's a venture class, which is less hands-on for us than our primary mission, but and it's for spacecraft that can tolerate a lot of risk. So if there's some kind of sensitivity to contamination or to some kind of electrical interference, those are more risky, meaning they could fail, or if they're highly expensive spacecraft, then we wouldn't want to put them on that, the lighter version, the bigger version of our contracts. So that was a good question. Okay, yes?
I saw that you guys, for the Pegasus, used to transport an L-1011. How long do you guys plan on still using that aircraft?
Well, the Pegasus program is over. They don't have any more Pegasus that they're going to be launching. So they're using the L-1011 for other things. We used to, in the shuttle program, we would land in Vandenberg out on the West Coast or at White Sands, because in the beginning of the shuttle program, it was new and we were trying to be risk averse. So we landed in areas that wasn't very well populated. And in order to get it back to Florida so that we could process it, we would load it on an L-1011. It would be on top of the aircraft, and the aircraft would carry it back to Florida, and then we would offload it and then process it. It's a good question. Yes? What kind of stuff do you do and learn in the internship? I'm going to let Katie answer that one because she's going to have an intern next year.
Okay, so you have a project that is specific to your mentor. So you're basically doing like, it's kind of like a fancy apprenticeship. So for example, I do the solar cycle. So my intern will be doing the research of the sun and what that will be, how you predict that, and they will learn how to model those predictions. Now, say you had a internship in propulsion, then you would be shadowing the propulsion meetings and doing the verification checks for the propulsion systems. So it depends on what that mentor is doing. So it's always a good idea to pick the internship with the mentor that you fit with the best over the internship name. Because you may love the mentor at one program more than the other. So you always want the best mentor for you. Okay. Question? Okay, so internships are very competitive. Example, when I was so we have about, in our program of 300 people, I would say we have like 5 to 10 internships. But it varies agency to agency, or center to center and program to program. Example, when I was working at Los Alamos, there were 10,000 applicants for a few hundred internships. Now, was I better than the other thousands of people? Absolutely not. It's to get an internship, the best thing is to network with potential mentors, either through conferences you attend. What I did was the rocketry. I tell students to go online and look up papers and scroll to the bottom and find emails and email questions to the engineers or scientists, and they will get back to you. That is the best way to get an internship. Any more questions?
There's one over there.
Okay, you.
Is New Horizons still active? It is.
Yeah, New Horizons is still inactive. Yep, yep. Any more questions? Yes, you. Okay, so the sun.
That's a great question for her.
Yeah. Okay, so the sun is gonna die, right? In millions of years,
Okay,
I'll be
we've
dead.
got
You'll be
another
dead. We'll all be dead.
thing we can
Yeah, don't worry about it. So what will happen? The sun burns hydrogen to helium. When it runs out of hydrogen, it's going to massively expand into a supergiant, red supergiant. Okay? It's going to just, whoosh, and then it's going to get larger again. Then, in that process, Earth will lose its atmosphere, and planets like Mercury and Venus will be inside of the supergiant. Then the planet's going to be so large that it's no longer stable, and it's going to collapse back and become a white dwarf. And then it's going to stay like that for eternity. So it won't kill, crash, it's just going to like eat it. Question? How much does it cost to do an internship? So internships are paid for you're an employee.
But they'd have to pay their own expenses.
Yeah.
If you got an internship and you had to go to the center to work, you would have to pay your own transportation to get there, your own housing, you have to rent a place to live, your own food. But they would give you a salary that should cover most of those expenses.
Yes.
So I saw a hand back here. Yes. Could you say that a little louder? Why don't we send all of our trash up to the sun to burn up? Well, I would say it's probably very expensive to do something like that. An average launch costs several $1 million just to get off the ground. We have to buy the rocket, which are several $1 million, and depending on the rocket, depends on how much space you have in the ferry to take trash. So it may not be very cost effective to do that. Yes? How long does it take to make a rocket? It depends on the rocket company. SpaceX can retrieve one of the boosters, or both of the boosters, and they can turn it around and within less than a week it's ready to fly again. How long it took them to actually make it the first time, I'm not sure, probably several weeks. They have their process down really, really well. So. Okay, we got some more information that we can share with you about the Mars 2020 launch. We'll go through that, and if there's any more questions, we'll take them until the end of the class is over. Did you have a question first?
How are they gonna take the people that are right now on the International Space Station back?
How are they going to get the astronauts that were stuck back? That's a good question. So we had a launch of the Starliner, and it was going to be, it took 2 astronauts. The intent was to go into space in the Starliner and then use the Starliner to safely return the astronauts back to the Earth. But once they docked at the International Space Station, they were concerned that the Starliner was not safe enough to bring the astronauts back. So they decided to leave them on the space station. And in about 6 months, they're going to be bringing them back on one of the Dragon crew capsules from SpaceX. So they have a crew rotation. About every 4 to 6 months, they rotate the crew, and they're making plans for those 2 astronauts to come back safely. They did return the Starliner, and it was a safe return. They could have done it, but it just wasn't worth the risk. We've lost too many astronauts, and we did not want to take that chance. So, okay. Go ahead.
What does an astronaut's life look like after they return? Do they get job opportunities after, or do they just get back out?
Okay, so she asked, what did the astronaut's life look like after they had been in space? It just kind of depends on the astronaut and what they want to do. They are celebrities. Pretty exciting to be an astronaut, to have gone into space, worked into space, walked on the moon. I was at a conference about 5 years ago, and Buzz Aldrin, the first man on the moon, he was our keynote speaker. So he gets paid to do speaking engagements, and he gets paid a lot of money for that. So we've had some astronauts become CEOs of aerospace. One astronaut, Andy Allen, that I know, he created his own aerospace company. It's called Aerodyne. My son actually works for Aerodyne, and he's doing a lot of work at Kennedy Space Center and other contracts. So it kind of depends on what they're interested in. Some of them are career astronauts. Some of the shuttle astronauts repeated their trip over and over and over again to go to the space station, work, and live on board the space station. So it's just kind of up to them. Did you have a question?
What will they do with the ISS? When will they retire it, and what will they do with it?
It's gonna crash into the ocean.
Okay, so he asked, what are they going to do when they retire the International Space Station? A couple years, they're going to be retiring it, and then they're going to fire some propulsion to make it go into the Earth's atmosphere and burn up. Sadly. So, okay, go ahead. Do I know Neil Armstrong? No, I do not. Do you know Neil Armstrong?
He's dead.
I know, but did you meet him in your lifetime?
No, only Buzz.
I've met Buzz, met Andy Allen, Mike McCulley, several astronauts.
Yeah.
Rick Sturfos. Yes. Wait a minute, I gotta get closer so I can hear. Well, they're on the International Space Station, and they actually have jobs up there. So they're not just sitting there watching TV or anything. They're actually working in space. So they're going to keep them gainfully employed for the next 6 months until they bring them back. And we see them on camera, so we know they're safe. So. Okay, I'm going to show you just one more mission. This is Mars 2020. So in 2020, July of 2020, we sent the Perseverance rover and the Ingenuity helicopter to Mars. And it was a big deal for us because that was a very heavy payload. So this is the fairing. It's the top of the rocket. And you can see it's open here on the side, and that's where we put the payload. This picture of the apparatus. This is a sky crane. You can see that. And what it did was it came down to the surface, and then it lowered the rover. The thing isn't working. It lowered the rover down to the surface, gently to the surface. And this is what it looked like. I'm going to see if there's any video. You can see that happened in 2020, right in the midst of COVID. It was a really big deal for all of us because we were trying to learn how to work and deal with COVID. Everybody was wearing masks. We had to be certain distances apart. So it was quite a challenge to get that one off the ground. So we were successful in launching the Mars 2020. So this is an example of the rover on the far left. We've got the little helicopter, the Ingenuity helicopter. It said that it made 72 flights before it broke one of its rotor, and now it's not able to fly anymore. So that's unfortunately a dead helicopter. But we got way more flights out of it than we were expecting. So that's pretty cool. And then that's the surface of Mars. So what's next when it comes to the Martian exploration? Well, they've come up with this idea of Mars sample return. That's where the rover is going to collect samples, about 60 different samples from different places in Mars, different areas within Mars. It's going to collect these samples, put them in a canister, and then bring it back to Earth for us to study the Martian soil. So this is what it's going to look like. They've got the helicopter here, they've got the rover. This is the capsule they're going to load all of the samples into. This is the sky crane that's going to help relaunch it, and then it's going to collect up with this spacecraft to come back to Earth. So I've got a video image of what that's supposed to look like. We've got the Mars sample return on dock for, I think it's at least a year in the future. We're still working on it. I'll get your question in just a minute. So the capsule is going to Mars. It's going to land that spacecraft. It's going to meet up with the rover. You see it's landing. And then the rover is going to go over to that piece of equipment and load all of the capsules that it had collected into these containers. So that's the capsule that has the Martian rocks and soil. You can see how many different samples that rover is going to collect. It's going to close it up. It's going to launch it back into space. There it goes. It's going to launch back. It's going to rendezvous with that other spacecraft that you saw in the image before. It's just amazing technology, the engineering that has to go into this, the preciseness. Can you imagine if they were just a little bit off? So now it's going to be heading back to Earth. It's going to meet up with the spacecraft first. It's going to propel it even further. It's going to launch it from the spacecraft. And once it gets back close to Earth, it's going to send those samples back. It's going to have a parachute to slow the descent, and we will have some Martian soil that we will be able to sample. It's pretty cool, isn't it? Okay, what was your question? What's what? I'm sorry, I don't understand your question. What's under the rover? The Martian soil? Is that what you mean?
Okay, so are you asking what's inside the Martian planet?
What's under the rover?
What's under the rover? Like under the tires?
It's just feet.
Yeah, it's just
like,
the feet. It's just the.
And wheels to keep it stable, to help it move around.
Yeah, it's just the instruments to keep it stable and move. Okay.
Okay, some more. You want to go over there?
Yeah. What question do you have?
So once you get this Martian soil, what kind of tests do you do?
Okay, that's a good question. Okay. Yeah. So the question is, what would we do with the samples from the Martian soil? So there are labs, like at Marshall Space Flight Center and JPL and Goddard, where they actually have geologists analyze the rocks, and they do a comparison to see what's the composition of this soil. And they look for different things, like they look at if there's, like for the moon, for example, there's the exploration, can we use anything as a energy resource? In Mars, are there any evidence of microbiology, like life, those things? So they go through those, like kind of like a forensic analysis of the geology. It's really cool. Any more?
There's a
Yes?
question over there.
Okay. Where?
There's two questions over there, and there's a question.
Okay, I'll go here, then you guys. Question?
How many different surfaces do we know of on Mars? Like different kinds of surfaces?
Okay. So you have different the question is, how many different surfaces do we have on Mars? You have different soil composition levels. So it's a planet, and there's going to be, depending on what happened from a geology standpoint, is what's going to be So say you had an earthquake, right? You're going to have a tear or a fracture, and so you're going to have things come up or down. So it depends on what creates that mix. You could also have, there could be a prior water source, maybe a million or however long ago. That's going to leave a different composition level. If a meteorite actually strikes a surface of a planet, you're going to have what's called a shocked quartz or a shocked level, where the rocks actually fracture the crystal structure. So there's different, it could be endless, basically. Next questions? Yes, you with the headphones?
Have we ever lost samples on the return?
No, but if you guys, have we lost samples on our return? No, but there was an FBI case. There was an intern at Marshall Space Flight Center who was studying lunar rocks. This intern tried selling the lunar rocks on the black market. Yep. The person he tried selling them to immediately notified the FBI. The FBI couldn't pursue the case unless he actually did it. No one thought he managed to actually carry the lunar samples out of the NASA building unnoticed. He threw away all of the Apollo research notes into the dumpster, took the samples to the diner, and tried selling them to an FBI agent. He is still in jail, and those lunar samples were destroyed forever. Yep. And we lost that. There was only one copy of those Apollo research notes. Those are gone forever. So that is how we lost a lot of our samples. His wife was very mad when she found out. Gosh. Okay, the question is, are aliens real? All right. Alien means extraterrestrial life. Life does not have to be defined as a humanoid or Homo sapien. It could be bacteria. It could be a plant. It could also be any form. Now, the universe is so large that we have thousands of galaxies, and we haven't even explored 1% of our own galaxy. So statistically speaking, do you really think that we are the only planet with any form of life? Right. Okay. Yes, yeah, I mean, I'm
There's a question over
You said you're collecting samples from Mars. What are you gonna do based on the information you gain from all this?
research, see if there's some, the question is, what are we going to do with the research based on the samples? It could give us information about energy resources. Now, we can still to this day not send an astronaut to Mars. You would die of cancer before you even arrived. Yeah, with the radiation exposure. It's impossible to send it, so we have to rely on robots. But it could be an energy source. If we ever find a way to be quickly sent there, it could be a source of energy for astronauts. It could also be information about life. There could be element research. It could be medical. You never know what you're going to find.
There's
Another
a question back there.
back there. Have I ever seen an alien?
Only in movies.
Only in movies, but I've seen alien-looking people, but they were from my hometown, so that explains it.